Good day everyone, my name is Carl J. Rivadavia. In this lesson, we're going to talk about metamorphic rocks. The term metamorphic means to change form. Metamorphic rocks originate from pre-existing igneous, sedimentary, or earlier metamorphic rocks. Their transformation occurs under conditions of intense heat and pressure, typically found deep within the Earth's crust or at tectonic plate boundaries. This process alters the mineral composition and structure of the original rock without melting it, resulting in new textures and mineral assemblages. The key factors in metamorphism include heat, which exceeds 200 degrees Celsius and causes minerals to recrystallize into new forms. Another factor is the pressure, which compacts the rock and can lead to foliation, where minerals align in parallel layers. And lastly, hot mineral-rich fluids that enhance metamorphic reactions and facilitate the growth of new minerals. These processes create a diverse range of metamorphic rocks such as schist, gneiss, and marble, each with distinct characteristics and origins. Metamorphic rocks are significant in understanding geological processes and also play a vital role in construction and as sources of valuable minerals.
Good day, I am Ordonia and I will discuss about the types of metamorphic rocks. There are two types of metamorphic rocks, foliated and non-foliated. Each is classified according to its composition and texture. So, when we say composition, it refers to a rock's chemical and mineral makeup, while texture refers to the physical appearance of a rock, such as size, shape, and arrangement of mineral grains and crystals. The figure on the screen is a metamorphic rock called gneiss. Now, let us proceed to the next slides to identify whether it is foliated or non-foliated metamorphic rock. Again, metamorphic rocks are classified two ways, foliated and non-foliated. Let us start with the foliated metamorphic rock first. Foliated metamorphic rocks are those in which the minerals have been flattened and pushed down into parallel layers. The bands in foliated metamorphic rock look like pages in a book. Examples of foliated rocks are slate, shale, and gneiss, which was shown before. Take a closer look at the picture. It is flat and has stripes or bands that are arranged in parallel layers. Here is what slate, shale, and gneiss looks like. Shale is a parent rock that can eventually transform into a slate and gneiss under heat and pressure. Due to its fine grain size, shale has a smooth or gritty feel and the individual grains are not visible. Slate. Slate forms when shale is subjected to low-grade metamorphism or moderate pressure and heat. It is hard and brittle type of rock, although it is smooth to the touch. The last one is gneiss. Gneiss forms from high-grade metamorphism or high pressure and temperature. It has distinct banding and coarse-grained texture. It is typically hard and resistant due to its composition. It is also suitable for construction and building stone. So, foliated rocks are minerals that have been flattened and pushed into parallel layers. It has distinctive and repetitive layers. Examples are shale, a parent rock, slate, a low-grade metamorphic rock, and gneiss from a high-grade metamorphism. Shale formed first, transforming into slate because of pressure, and finally transformed to gneiss to a higher metamorphic conditions.
Hi everyone, we're down to the last part of today's lesson. I'm Micaela Pereño, your third and final reporter. We're going to finish up by talking about non-foliated metamorphic rocks, another unique and fascinating category of rocks. So let's start with a quick recap of what we've learned so far. The term metamorphic means to change, which these rocks form due to intense heat and pressure, so on and so forth. There's two categories of it, and you've already learned about foliated rocks, which have layers, and now let's focus on the non-foliated ones. So to make it easier to understand, non-foliated rocks are different because they do not have layers. In foliated rocks, minerals are flattened and line up in a parallel layers due to pressure. However, in non-foliated rocks, the minerals are arranged randomly, giving these rocks a more uniform appearance. Now, let's explore some common examples of non-foliated rocks. The first one is quartzite. This rock forms from sandstone and is known for being incredibly tough. It is harder than glass. It's often used for countertops and construction because of its durability and resistance to weathering. Next one is marble. This rock, which forms from limestone, is famous for its beauty and smooth texture. It's often used in sculptures and architecture. Here's a fun fact that is related to that. Many of the world's greatest sculptures, like Michelangelo's David, were carved from marble. The last one is the anthracite coal. It is the highest rank of coal. This is a very hard and carbon-rich form of coal. It produces more energy than other types of coal and burns with very little smoke, making it one of the cleanest forms of coal for energy production. Now, the question is, why do you think these rocks don't have layers like foliated ones? The key is in how they form. Non-foliated rocks are often created under conditions of high heat but less pressure, especially in what we call contact metamorphism. This happens when rocks are heated by nearby magma. Since there isn't enough pressure to flatten the minerals into layers, the minerals stay randomly arranged, giving these rocks their smooth, even texture. To summarize, non-foliated rocks may not have the layers of foliated rocks, but they're still incredibly important, whether it's quartzite's toughness, marble's elegance, or anthracite's clean energy. These rocks play a big role in our world. Thank you for listening, and that concludes our lesson on metamorphic rocks. We hope you found it as interesting as we did.